Hello, my name is Rob Garner. I'm a computer programming instructor, and today I'm going to talk about Git. So this presentation is prepared by me and based on a book called Pro-Git by Scott Chacon and Ben Straub, and it's located here. This is a great book. It's free, and it's available on Git SCM. I highly recommend getting this ebook and reading it. I'm just going to be reviewing the first 3 chapters, which is usually sufficient for a person to do most of the things you need to do as a developer using Git. There's also a lot of other things in here that are good to read, but the first 2 chapters you definitely want to go over in detail. So the first chapter of this book is about getting started with Git. And there's 2 things that people hear about with the word Git. One is Git and GitHub. So the difference is that Git is the technology and GitHub is a website that uses Git to provide you the ability to store repositories online. There's several sources for learning Git, including my own tutorial here. You can also go to Code School. There's the book we referenced, and there's a number of different sources. So there are many different places you can learn about Git. So first, to understand Git, you need to understand what version control is. And so version control essentially is the technology that gives you the ability to revert files back to a previous state. And so in order to do this, what version control systems do is they store your files in different states over time. And there's a lot of different things that get added to this, including identifying who made the last changes and allowing you to maybe document issues and a whole lot of things. But essentially, think of it as being similar to, say, if you've ever been working on a document or file or program and you keep saving versions and adding, say, a version number at the end, like version 1, version 2, version 3. This automates that so you don't have to do that. There's actually different types of version control. There's local version control, centralized, and distributed version control. Local version control systems basically are used to store changes all on one system, and that example of using version numbers on a file is a simple way to maybe do some form of version control, but it's potentially error prone. And sometimes, you forget which directory things are in, and you mess up the numbers. So that was a common experience. And at one point, developers created local version control systems to simplify that process. And so it might look like this. You have a version database, and it's got the different versions of the file, and you check out the one you want and work on it. And when you check it back in, it saves a new version. Another form of version control, which was an adaptation of that, is called centralized version control systems. And basically, this becomes necessary when you have multiple people working on the same project. Without version control, you have a lot of overhead managing which file you're working on, and only one person maybe can check out a file at a time, and it becomes difficult to manage a team that way. So centralized version control systems like CVS, Subversion, Perforce, and others basically create a system where either on a local network or on the web, you could store the official version of a repository online, and people could then download it, make changes, and then check it back into that centralized location. There are still many version control systems which are still centralized version control systems. And so this might look like this. You have some central server. This could be on a LAN, or this could be on, it could be on a network, or it could be in the web. And you have two computers that are, maybe working with this. They check out a file and they work on it, and then when they're done, they check it into central version control. And so one of the advantages of some of the advantages of centralized version controls are everyone knows to a certain degree what everyone else on the project is doing. Administrators have fine-grained control over who can do what, and it's easier to administrate a CVS system, a central version control system, than it is to deal with local databases on every client. The disadvantage is you have a kind of single point of failure. If that server goes down, then no one can work on that until it comes back up. If the hard disk in the central database becomes corrupted and you aren't maintaining backups, then you've lost those versions. The third type is distributed version control systems, and these are systems such as Git, Mercurial, Bazaar, Darks, and a number of others. And so when you check out from a distributed version control system, you don't just get the file you're working on or the snapshot of the latest version. You actually can download essentially the entire repository. And so every checkout is a full backup of all the data. So this might look something like this. You have a server computer with multiple versions, and this whole database gets brought down to each computer, and then locally you check out the files and modify the files you want. And the nice thing about this is many of these systems deal pretty well with having several remote repositories. You can collaborate with different groups of people in different ways, and allows you to set up several types of workflows that aren't possible with centralized systems. And the other advantage is you have a full backup. So if this server goes down, everyone's got a version. You can just upload one of the existing versions and you're back up and running. And it also allows you to fork a repository and make a new version of this whole thing, and another team can be working on that in a different way. There's a lot of flexibility with that type of system. So where did this come from? Well, the Linux kernel is an open source software which is has a really large scope, and basically the existing version control systems were creating some problems for managing this large open source project. And so this prompted the creation of a new source control system. The original one, BitKeeper, just didn't quite do what they needed it to, and so that's what prompted the creation of Git. So the goals were to have something that was fast, simple in design, strong support for nonlinear development, fully distributed, and able to handle large projects like the Linux kernel. And so that's what we got. We got Git is fast, it's efficient with large projects, and it has a branching system for nonlinear development. So the basics of Git. So what you have with Git are snapshots, not differences. So most other systems store information as a list of file-based changes. And so they keep a set of files, and changes are made to each file over time. And so it might look like this. You have version 1, version 2. And you can see here you have let's say you start off with files A, B, and C. And then version 2, you have this file which is a delta, which identifies what was changed in file A. And each version is basically a delta from its previous version. Git doesn't think of or store data this way. Instead, Git thinks of its data more like a set of snapshots of a miniature file system. Every time you commit or save the state of your project, Git basically takes a picture of what all your files look like at that moment and stores a reference to the snapshot. If files have not changed, Git doesn't store the file again. It just a link to the previous identical file it has already stored. And so it thinks of it as more of a stream of snapshots. So you can see here version 2 has either, so we have file A, B, and C, and then here A1 is a different file than A. It's a one modification. B is the same thing, so there's no need to change that. And so this is just a pointer to the previous version. C1 is the modified file. Then we go through here, and you can see eventually all of these have modifications. And so this has, it's not just the changes, but it's either the file or pointer. And so it's kind of just a different way of slicing, the same problem. And what this means is that nearly every operation is local. So Git only needs local files and resources to operate. So you can actually work on the Git repo even if you don't have a connection to the server on the network or on the web, because you have everything in that repo. And so that gives you this offline capability. So you can get on an airplane, a train, keep working, and then as soon as you get back up and get connectivity, then a synchronization can be done, and all the changes get uploaded to the main server. Git uses checksums with each file, and so it actually uses a hash to figure out what the changes are. And so this actually gives a lot of integrity with this, because everything's being checksummed all the time. And so it uses SHA-1 hash. It's a 40-character string composed of a hexadecimal character and calculated based on the contents of a file directly. So if you make a modification of a file, the hash will change, and that's how Git knows that you've made a modification to the file, and then it stores the new version. So when you do actions in Git, nearly all of them only add data to the Git database. It's not removing things. And so it's actually very difficult to do anything with Git that is not undoable or that erases data. You can lose or mess up changes, but everything gets saved. Now, this is important to realize from a security perspective, is that if you check in something like a key or a password, that stays in there all the time, because Git doesn't get rid of anything. And so you have to do a lot of things to clear out a hash or a password. If you ever do that, the easiest way is probably just to change the hash or the password. So Git has three main states that your files can reside in: committed, data is safely stored; modified, you have changed the file but have not committed it to your database; and then staged, you have marked a modified file and its current version to go into your next commit snapshot. So these terms are important to understand and use. So committed, so it starts off staged, or it starts off modified, then it becomes staged, and then you commit. So it kind of looks like this. So you have a Git repository. You check out a file into your working directory. Once you've made your changes, you say stage these fixes. And then once you have a bunch of fixes that have been staged, you then tell Git to commit those, and then they're back in the repo, and the cycle begins again. So this cycle is the fundamental cycle for how Git works, and you need to understand this in order to work with Git. So metadata and object database for your project is what's in that .git repository. And when you clone a repository, which is another term, when you clone a repository, you get this .git directory. And this is, your working directory is a single checkout of one version of the project. So your staging area is a file generally contained in your Git directory that stores information what will go into your next commit. Sometimes referred to as the index. And so this is your basic workflow. Modify the files in your working directory, stage the files, and then do a commit. And that commit then saves it in your Git directory. So until you do a commit, nothing is saved in your repo. And so a file has these different stages. If it was changed since it was last checked out, then it's been modified. If you then were to stage it, it's considered staged. And then when you do a commit, it's been committed. So there are a lot of different ways to use Git. There are command line tools and graphic user interfaces. So the book walks you through using it in the command line, and I think this is the best way to learn initially, so that you understand what's happening. You can use Git on the command line. Yeah. So installing Git. So you have to install it beforehand. And there's several different ways you can install it as a package via another installer or download the source code. You can install it on Linux using yum or apt-get. And if you go to git sem download Linux, it'll give you the options here. So here's git sem, and if you look at downloads, it gives you the different options, and you follow the instructions. So here's Linux, and it gives you, whatever distribution you're using, it tells you how to do that. If you're installing on Mac, again, you can go to the website and click on that. It gives you instructions for Mac. And then Windows, the same thing. And there's installers that you can install, or there's also portable versions that you can use as well. You can also install from source if you wish. So there are some things once you have Git on your system that you'll need to do to customize your Git environment. And first is the Git config. And so there's some config variables that can be stored in different places. And basically it kind of works in a hierarchy. So, you can, your Git configuration can be stored on the entire machine or for the user or in each directory. And we'll see that in Windows systems you have a .config file. So the first thing you should do when you install Git is to set your username and email address. So let's see, I've got Git installed. I'm going to open up a command window, a command prompt. And so if I type Git, I get all the commands. So I can look at my git config by saying git config -- list, and it shows all the current settings. So I've already set my username and my email. And then there's other settings in here that you set basically by saying git config, and then in this case, if you want to set the global, then you would put that in. So before you start, you definitely want to put your username and your email address that you're going to use to associate with your Git. So the global option. So if you do this for the global option, then once you set those things, it applies all the time. If you want to override that, you can just reissue that command and change what your email address or your name is. You can also set the default editor. And so let's see, if I wanted to, let's see, which editor do I have? So in order to set which editor I want, I have to find the location of my editor. On a Windows system, that would typically be in program.cs. And here's where Notepad++ is for me. So I want that file there. I'm going to copy this path. And yep, there it says that it's picked up that I want to use Notepad++ as my default editor. Yeah, and then to see what we have set, we can do config.list. You also check what Git thinks. With the key, so if I put git config user.name, it tells me what I have set. And there's a number of help and manual commands you can use to look up information. And so here's an example of if you do the manual command, git help config, it'll actually give you kind of a web page and give you information on that. So we went over basically what Git is and how to configure it. Thank you.